Welcome my students. Now our discussion is about energy. We have already gone through work and power. What is energy? Energy is the capacity of doing work. It is the capacity of doing work. So more is the work done, more is the energy. And if you do a large quantity of work, then a large quantity of energy will be incurred. And energy is measured by the work done. Energy equal to work. So the unit of energy and work will be same. Unit of energy and work same. In CGS, unit of energy arg, that is unit of work arg, and in SI, unit of energy, that is work, is joule. So if you memorize the units of work in CGS and SI system, those will be the units of energy in CGS and SI system, and we can recall the gravitational unit of work, that is energy. In CGS it is gram centimeter and in SI it is kg meter. And 1 gram centimeter equal to 980 arg you have known, and 1 kg meter equal to 9.8 joule you have also known. So what is the relation or difference between energy and power? Power is related to time. Power is the work done in unit time, but energy is not related to time. Energy is the total capacity of doing work. So energy will be judged by the total quantity of work. Say a machine can perform 1000 joules of work. Its energy is 1000 joules. Now if 1000 joule of work done in 50 seconds, then power equal to work done 1000 joule by 50 seconds. That is equal to 20 joule per second or 20 watt. So power is obtained by dividing the work done by time, but its energy, in this case the energy of the machine is 1000 joule. So energy is not related to time, but power is related to time. This is the main difference between power and energy. Now you know there are different types of energy: sound energy, light energy, heat energy, electrical energy, chemical energy, nuclear energy, magnetic energy, etc. Now our discussion is regarding mechanical energy. There are two types of mechanical energy. Mechanical energy, first one is potential energy, and second one is kinetic energy. Now what is potential energy? Potential energy, the energy possessed by a body due to configuration. Configuration means change of shape or change of normal position is called potential energy. So energy possessed by a body due to configuration or change of normal position is called potential energy. If you take a body from the ground to a upper level, the body possesses some potential energy potential, and this potential energy is measured by the mass of the body into acceleration due to gravity into height. That is mgh. It is a formula of quantity of potential energy possessed by a body. It is positional potential energy. This potential energy is possessed by the body due to change of position. And due to change of position, potential energy can also be acquired by a body. I think you know catapult. In a catapult, if you elongated the rubber, then some potential energy is produced in the rubber, and a piece of brick or stone connected with the catapult, if it is free, then it will move. That is, potential energy will be converted into kinetic energy. And in this manner, potential energy can be converted into kinetic energy, and kinetic energy can be converted into potential energy. Now, kinetic energy. What is kinetic energy? Kinetic energy is the energy possessed by a moving body by virtue of its motion. So, kinetic energy is possessed by a moving body. When a body is at rest, it has no kinetic energy. When a body moves, then due to motion, it will possess some energy, and that is kinetic energy. And this kinetic energy kinetic, Ek, will be measured by the formula half mv square. That is half into mass into velocity square. More will be the mass, more will be the kinetic energy, more will be the velocity, more will be the kinetic energy. And kinetic energy is increased by the square of the velocity. So if velocity increases, then kinetic energy will be increased by its square. If you are kicking a football, and the football will possess some kinetic energy, and a first bowler is bowling with a kicked ball, and it will possess some kinetic energy. Now, though the football has greater mass, but the kicked ball, it is football and it is kicked ball, it has less mass, but as its velocity is much greater, then it will possess more kinetic energy. And if football and a kicked ball strikes you, then it will be more painful by the stroke of the kicked ball, because it gains more kinetic energy due to its motion, due to its more velocity. So this is about kinetic energy, and keep in your mind that its formula is half mv square. And potential energy can be converted into kinetic energy, and kinetic energy can be converted into potential energy. I am giving you an example. If a body is thrown on the sky, say a body is thrown on the sky, the body was at rest, then when it is thrown, it acquires some kinetic energy. And at this point, it becomes at rest for a certain second fraction of moment, then all of the kinetic energy will be converted into potential energy. And now the body again falls. When it is falling, then potential energy is again converted into kinetic energy. So during throwing a stone or throwing a body, it first possesses kinetic energy, and after some time, it stops for a fraction of a second. It possesses all of the kinetic energy is converted into potential energy, and during its fall, the total potential energy gradually converted into kinetic energy, potential energy gradually decreases, and kinetic energy gradually increases. At the midway, the potential energy kinetic energy will be equal, and before touching the ground, all of the energy is converted into kinetic energy, and after touching the ground, it is converted into sound energy, sound plus heat energy. So this is the conversion of energy for a falling body. And we have shown that in this case kinetic energy is converted into potential, potential energy is converted into kinetic energy, such and such. And keep in your mind that the total quantity of potential energy and kinetic energy for a free falling body will be constant. Now we'll prove it. Prove that EP, that is potential energy, and EK, kinetic energy, sum total of potential energy and kinetic energy for a free falling body is constant. We'll prove it. Say the body has been lifted up to a height h. So at a point A, and then it starts falling from A, at the midpoint B, and it is the ground C. At A, potential energy equal to mgh if m be the mass of the body and it has been lifted to a height h. G is the acceleration due to gravity. Let the distance AB equal to x. This is x AB. So BC equal to h minus x. Therefore, at B, EP potential energy equal to mg into height, that is h minus x. At B, kinetic energy Ek equal to half mv square. Now we know v square equal to u square plus 2as. Here u equal to 0 because at A the body was at rest, so u was 0 plus 2. Here acceleration is acceleration due to gravity g, and s equal to the distance covered by the body, displacement is s, that is equal to x. So it is equal to 2gx. So in the equation 2, we have known Ek equal to half mv square. By substituting v square by 2gx, we can write half m into 2gx. 2 to cancel, that is equal to mgx. This is 3. Now at B, total of potential energy and kinetic energy EP plus Ek equal to mg into h minus x plus mgx, that is equal to mgh minus mgx plus mgx. Cancelled mgx, mgx. that is mgh. So at the midpoint, the total of potential energy and kinetic energy is also mgh. And now, before touching the ground, what will be the sum total of potential and kinetic energy? Now, just before touching the ground at C, potential energy equal to mg into h0, that is equal to 0. Kinetic energy equal to half mv square. Now here v square equal to u square plus 2as again. U equal to 0, u was 0, 2 into g into s means h. That is equal to 2gh. Therefore, at C, kinetic energy equal to half mv square, that is half into m into 2gh, that is equal to mgh. So, kinetic energy plus potential energy at C equal to 0 plus mgh, that is mgh. So it is proved that any point during of a falling body, the total quantity of potential energy and kinetic energy remain constant. And this is regarding work, power and energy. Thank you, my students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.